Hey guys, and welcome back to another video. In this session, I want to take a look at basic threading in Python. So I'll be doing a quick example. I'll briefly explain kind of what threading is from a kind of a high-level point of view. We'll end the video by looking at a module, which is a pip installable one on PyPy, which is called Grequests. And it's a really nice way to make a lot of requests to a web server or an API in this kind of multi-threading fashion. So traditionally, what we'd expect, especially if you're new to Python, is this kind of pattern here. Suppose you define a couple of tasks to do. So maybe these are just functions that are called. You might call one function, then the next here. So imagine, say, if these take, say, like 2 seconds each, right? So I'll do a quick hashtag here. Suppose this takes 2 seconds, and then we wait until it's done. Maybe this takes 2 seconds and this takes 2 seconds. That's like your kind of traditional kind of way of doing things consecutively. We do a task, wait till it's done, rinse, repeat, and off we go. That's pretty traditional. However, in this kind of multi-threading way of doing it, we kind of group tasks kind of a bit like this. So if I can put a hashtag here, you could actually do things like that. So you might say, okay, task 1 runs by itself, then task 2 and 3, those can run at the same time. So to get things to run at the same time, that's when threading comes in. So especially if you're making things like requests to an API, your computer can obviously go off and make multiple requests at the same time. You just need to know how to make Python actually do that for you. So rather than having a function that makes a request to an API, it brings back some data and prints it off on the screen, you could call that function in a loop and do it one by one, and that's fine. However, as I'll show in the example at the end of the video, we can kind of engineer Python to say, okay, here's 5 requests, go off and make them at the same time, wait for them all to finish, and then show me what they've done. Now, there's a whole lot of terminology with threading, so I'll try and keep it nice and simple. In your CPU, depending on what kind of computer you've obviously got more than one core. It could be, hopefully not a dual core, probably more powerful than that. It could be a quad core or more. It more than likely is. And those cores each have threads. Now, those threads basically allow for different things to happen at the same time within a core. And we're kind of, now this is a bit high level and a little bit loose of the terminology, but we're basically saying, here's some tasks. I want those tasks to occupy different threads, so therefore they can run at the same time. So, if you want, you could even do something a bit like this as well. So I could do task 1 here, we could do task 2 there, and we could also do task 3 here. Those 3 could all run concurrently, aka at the same time. And at the end, they could all finish, and then we have some result after this thread, and this thread have finished. So loosely, what we need 3 things, to be honest. We need some definition, so something to run. In this case, we'll do a simple function which waits for a couple of seconds. So we need to define something to go in a thread, like a task. We then need to start the thread, and once it's started, we then need to say, okay, let's wait till they finish. So we'll do it in this kind of 3-step process. We'll stop at each step, talk about what's going on, and then we'll just kind of do a nice and simple kind of clear as day example just to show you exactly how threading is working from a nice basic point of view. So we're going to keep this mega simple. I'm going to import time here. The reason I'm importing time is to simulate an expensive task happening. So let's then do def, myfunc, and then we'll do thread here. Say this has to be an integer, and this is a function that returns none. And then let's do a quick docstring. So we'll do some, let's say example function, to pass to a thread. Make sure I spell that one wrong. There we go. Okay, so some example function to pass to a thread. And then what we'll do in the function, we'll just define a task that takes a couple of seconds. So we'll do for I in range 1 to 6, and then we can say this is, we'll do it as an f string, so we can say thread something, so this will be the thread we've passed in here, running in loop blank like that, and then this will be the I here. So we'll put thread into there, and we'll then put I into here. Okay, nice and simple. Just to show this running, be quite useful. Call myfunc like this. I'll pass in 1 here, and then we'll then go down into the terminal and call this. So we can see there's my task. Now what I want to do to simulate this being an expensive function is do time.sleep of 1 here. So let's run that. And there we go. To take just a second, well, obviously 5 in this case. There we go. Now, if this was a sort of like a consecutive deal, we'd do something like this, right? So imagine if I clear the screen here. If we say run this function, it'll do its loop 1 to 6. It will then stop and then do this here. Let's just run that real quick. Okay, so that's my kind of consecutive style here. And of course, I'll say it again, like some situations, that's fine. If this is taking not too long at all and you're not too fussed about this happening at the same time as other stuff, then yeah, it might be okay. However, this situation here, if this is taking 5 seconds from this call, 5 seconds from this call, obviously our computers can do, they're more than capable of doing 2 of these at the same time. So we can say, right, let's multi-thread this. Let's make this run in one thread. We'll make this run in another thread, and we'll watch them go at the same time. The reason I did like 1 and 2 is because we can see like from obviously these ones here, these print statements are a result of this function, and of course these print statements here are a result of this function. So now we've got our target, we now need to pass this into the threading module and get it all imported and set up. So we'll do that now. So first thing I'll do is import threading here. Threading's already in the standard library, so don't worry about doing a pip install here. I now need to set this up down below my function. So I'll do thread1 equal to threading.thread, and we'll take a look at the these kind of type-ins here. So we can see it's got this target equals. This target here is basically like the workload to pass to that thread. And if we look further down, we should see args here. The args here just relate to the target. So if we pass in a function as the target, you pass in the args as 1. The args are passed to the target function. So if I just quickly do that as target is equal to my func here, and because don't worry about doing it like this. We're not. If you did this here, this would pass none to this. And of course, we're not calling the function here. We're passing a reference to the function so that the thread knows to put this function into the thread. And for the args input here, see how it says iterable any here. So it wants us to pass an iterable in. So that's why if I give it a tuple here, like that, that's absolutely fine. So it's basically, this is me just passing 1 to this here. And now what we want to do is do the start and the join here. So the start is it's actually a method that belongs to a threading object. So to prove this, if I do print dir of thread1, and we'll look at the methods that are associated with this threading object. There we go. We have the start method, and we have join as well. So it's start and join are the 2 we're going to use for this demo. So let me just quickly try thread1.start, and this is like kind of hitting the play button here. We want to clear the screen just for a second to get this guy going. There we go. So because I did thread.start, we're basically saying for this object, send it off to the thread and let it rip. Now I want to try something here. I want to do print finished. So I want to quickly show you the effect of like if you were to start a thread without using join, because there's quite an interesting side effect here. So see how we got finished. Now that's really interesting. So look at the ordering. Now the ordering might not make sense. It's like, well, how did it do this? Print this, but this is still going, and that's exactly where like the multi-threading element comes in. Now Python is effectively running in more than one thread. So imagine this whole program is one thread here. So we started from line 1, it's passed these comments, it's done nothing with them. It's gone off and done this. Because we've done all of this here, this has taken a separate flow of execution. Then our main thread has carried on. It's print finished, and it's just gone on as normal. So this bit here is almost like it's kind of gone off in the background without us really doing anything, which is pretty cool. However, it's not that desirable. We often quite want to wait for these to finish before moving on to something else, because in this case, I said print finished without waiting for this thread to finish and join the main flow of execution. So to basically bring that back, what we do is do thread1.join. Notice how it isn't finish or end. The join kind of refers to join back in with the main flow of execution. So this is like saying, off you go on your own, and then this bit here, waiting for it to finish off what it's doing, and then said, kind of like once you're back, then off we go. So now we get a greatly different effect. If we do clear and run this time, there we go. So this is waiting for that. This is kicked off the thread, waiting for it to come back, and now it's finished. And then it just goes on really. So let's try something else. Let's try and do thread2. So we'll define both of these guys here. we'll do args as 2 to this one. And all we need to do now, I can be really lazy here, can't I? I'll do thread2.start and then thread2.join. So now, because both our join statements here, these are going to wait, of course, this thread1.join waits for this flow of execution to finish, and thread2.join waits for this execution here to finish. So basically, it's going to start off these two threads in the background. These two are only going to really finish and move to line 26 once both those threads are finished what they're doing. Only then do we see finished in our main thread here. So it might look a bit messy this bit, but we can hit run and just see what it looks like. But what we should see now is both these functions kind of happening in the background in their own thread. So if we give that a run, there we go. So see, it's done like thread 1 2 1 2 2 1 2 1 2 1. Yeah, there you go. They're quite happily happening in the background. And then of course the thread1.join, that's just saying, yep, once you're back, we can carry on as we were. It's almost like a little side quest for your Python program to do. And I'll show you what happens if I do it without. So it did the start. We carried on back here, and these two are still kind of happy to chug along in the background and do their thing. In a nutshell, that's as basic as you can get with threading. So I'll reiterate this one more time, and then I want to show you this Grequests module, which in my opinion is absolutely amazing. So the whole idea of threading is to allow things to go off in the background and perform their own tasks. Your computers have multiple threads and cores for a reason, so that you can do multiple things at the same time. So to define a thread, we need to actually give it a target. In this case, we've given it a function which does a loop. We then need to start it off, and we do that just by calling the start method on your threaded object. We can then use .join to say, let's pause the main execution until that particular thread has finished. And then once you're home, we can carry on as we were. In this case, we started off two separate threads. Lines 24 and 25 just sort of said, yeah, once you're back here, we can move on. So of course, once the second thread finished, we could see this print, which is obviously in our main program. So with the basic one done, I'll quickly clear the screen and we'll take a look at Grequests. So I want to talk a bit about this first. Grequests, which I'm going to link the PyPy page to in the description. It is a pip installable package, so make sure you've got pip installed, and then it's as simple as doing effectively pip install Grequests. You probably get that there. Not with an F, make sure you spell that properly like I do. So it's pip installable, it's really nice, and to show this one I'm going to use 3 different API calls. This horrifically long API call here. So this is the open.meteor one, so you can basically give it a lat and long, and you give it kind of the parameters you want back. So I want wind speed, humidity, and I want current temperature as well, and I've given it 3 different sets of latitudes and longitudes. Now you could quite easily do a simple loop which says for each of these URLs, go and grab the data, and then put it into a dictionary from this one, then this one, and then this one. What Grequests will do is it will actually prepare the requests in the generator, and then given that generator, it will go off and then make concurrent requests to all 3 endpoints at the same time. So it saves you an awful lot of time, and in situations where you're calling lots of endpoints at once, I think using this is a much better way of doing it. First thing I want to do is do rex to kind of keep my unsent requests in, and I'm going to do the following here: Grequests.get of URL for URL in URLs. Now this should be a generator. I'm just going to check that's correct, so I'm going to print reqs like this here. Bring that up and hit run. Okay, so we can see a generator object gen expression at some memory address. Yeah, so we can see this is a generator. If I was to call next on one of my objects, we get this async request object. Now async, you may be familiar with it if you've done a bit of stuff in threading before. It stands for asynchronous, and there is another library called async.io. And what's going to happen now is these async request objects, they're basically going to be processed at the same time by Grequests. So it's going to go off to this, and this, do them all at the same time, and then give me the data back all in one go. So let's clear the screen and set that one up. So to set this up, we will do responses is equal to Grequests.map, and then I'm going to pass it the generator. So I'll pass reqs in here. I wanted to check that and check we have no errors. And there we go. It seemed to be pretty quick. So if we print off the raw responses here, let's print off what we get. We should see response 200, 200, 200. It's like your universal code for like all is okay. So what we could do is iterate over these for resp in responses. These actually return JSON objects. So if I do resp.json, this now returns me a dictionary. If I then do .keys, so I'm going to call the keys method on the dictionary object, this will show me what keys we have to play with. Okay, nice dictionary keys, latitude, longitude. Let's take, I don't know, let's do latitude just to kind of prove that we can extract a single key from this here. So if I do JSON of latitude, get rid of my extra doubles there, and let's see what we get. Okay, it's 52, 53, 54, so that corresponds to these here. And in a nutshell, that's what Grequests does. It's pretty cool, right? It's something I've used quite a lot in practice. So of course, this sort of situation when you're having to make multiple requests at the same time, if you want to kind of leverage the fact that your computer has multiple threads and CPUs, then why not use something like this to actually take advantage of those threads and CPUs? Of course, I'll leave the link to this PyPy page in the description, and I'll see you all in the next video. Cheers.